Okay, now we're going to do a little practice with those buffer action problems, looking at what happens if I add a strong acid or a strong base to a buffer. Okay, so let's take a look at this first one. We want to calculate the pH of a buffer prepared by adding 20 grams of ammonium chloride to enough 0.75 molar ammonia to produce 500 milliliters of solution. Now, if you remember, we worked this problem earlier, and so what we already know is we have this molarity of the base, this molarity of the acid, and our pH in that system was 0.9247. Alright, so let's take a look at what would happen is to the pH if we add 2 milliliters of 0.1 molar HCl. Alright, so let's take a look. So first of all, I didn't give you the Kb, but the Kb is 1.76 times 10 to the minus 5. So what's going to happen here is I'm adding acid, so I either can write I'm adding H plus or H3O plus. And if I look at my choices for what it's going to react with, it's going to react with the base, and it's going to give me ammonia. Okay. So I can first figure out how much of the acid I am adding by taking the molarity of the acid times the liters, and I get 0.0002 moles. I can take my ammonia and take my molarity, which is 0.750 times 0.075 liters, and I get 0.05625, right? I can take my ammonium molarity, right, which is right here, times 0.075 liters, and I get this many moles of ammonium. So all of the acid is going to be neutralized by the base, so all of that acid will go away and I'll have none left. I'll use just as much base as there was acid to neutralize, leaving that. And I'll pick up the same amount of ammonium as the water that I used, or the H plus that I used, leaving me with this. Okay, so if I look at my using my Henderson-Hasselbalch on the final situation here, I have pH equals negative of the log of the Ka. Now what I'm given is the Kb, so I'm going to take 1 times 10 to the minus 14 divided by Kb. That will give me my Ka. And if I do the negative of the log of that, of course that's going to give me the pKa, plus the log of the concentration of the base, which is here, over the acid, which is here, and I get a pH of 9.243. So very close to the pH of what I already had. It went down, which makes sense because I'm adding acid, which should make the pH go down. Okay, let's take a look at the same buffer. This time I'm adding KOH, and I'm adding it to more of the buffer. Okay. So again, if I'm adding OH, my choices for what to add it for are going to be, I'm going to add it to the conjugate acid here, and I'm going to end up with ammonia. I can figure out how much of the OH, how many moles of the OH I start with by multiplying 0.003 liters times 0.1 molar, and I get 0.003. Right? I can do the same thing for ammonium. I can take my 0.748 molar I start with, and I'm using 100 milliliters of the buffer, so I'm going to put that there, and that moles goes here. I'm going to do the same thing with NH3. I start with 0.75 molar. I'm going to use 0.1 liters, so I end up with 0.075 moles of that. Okay, so all of the base is going to get neutralized, leaving none. I'm going to use the same amount of acid to neutralize that base and subtract it from my original amount. I'm going to add that same amount to my ammonia and end up with this amount. Okay, so once again, my pH is going to be my pKa, which because I don't have a Ka here, I was given a Kb, right? And it's going to be 1 times 10 to the minus 14th over the Kb, plus the log of the concentration of base, which is here, over the concentration of acid, which is here, and what I get is 9.282. Okay, so I'm adding a little bit more base. I did go up from 9.247 to 9.282. The pH should go up because I'm adding base, and it went up more than a little tiny bit like I've seen in some others, but I've got more of it. Okay. All right. Let's take a quick look at a couple more things. So here I'm adding a small amount of HBr to a buffer, which is 0.15 molar of this acid and this salt. And the question is, what species in the buffer will neutralize the acid? Okay, so I've got H plus from the HBr, and it's not gonna be neutralized by an acid, so it must be neutralized by this. And I write it as a net ionic, right? And then when I do that, I'm going to end up with HCHO2. Okay? Let's take a look at the next one. All right. This time is that the same question? I think did this twice. All right. My bad. All right, here I am adding a base to the same buffer. And again, we got to write the neutralization reaction. So I always start with what I'm adding. And I'm adding a hydroxyl, I'm adding a base. So I'm going to have to neutralize it with an acid. My acid is here. And the proton is going to get donated. I'm going to end up with CHO2 minus plus water, right? So that's going to do that. Okay, I think I just put these in twice. Alright, so this one I want to calculate the pH of let's do this one. Let's do number 4. Calculate the pH of a solution if 2 milliliters of 0.15 molar NaOH is added to 100 milliliters of buffer, which has this and this. Okay, so let's take a look. So I'm starting with hydroxide. I'm adding a strong base, right? So I'm going to say the OH minus plus the acid is going to, the proton's going to leave, and I'm going to end up with CHO2 minus plus water, right? Don't need to worry about the water in the table. My ICF, my initial concentration of the base, I'm going to take 0.002 liters times 0.15 molar, and that's going to give me 3 times 10 to the minus 4 moles. I'm going to take my 10 molar of the acid, and I am using, let me see, 100 milliliters of it. So that's going to be a 0.01 moles. And if I have 0.15 molar of the, conjugate base times 0.1 liters, that's going to be 0.15 moles there. Okay, so all of my, looking at the change line, all of my base is going to get used. It's going to get neutralized, right? I'm going to use the amount of acid that was necessary to make that happen. And I'm going to add that same amount here. It should be -4. Okay, and when I'm done, I'm going to end up with all my strong bases gone. I have 0.0097 left of the weak acid, and I have 0.0153 moles of the base. Okay, so pH is going to equal pKa plus the log of the base over the acid, and my pKa, my Ka is 1.8 times 10 to the minus 4, so this is negative of the log of that, plus the log of my base, which is this, over my acid, 0.0153 over 0.0097, and when I do that, I am going to get a pH of 3.943. Alright, we're going to stop right there.